So, if you follow the world of artificial intelligence, you know that the headlines have been nothing short of astonishing lately.
Hmm.
We're talking about these large frontier models, the heavy hitters like GPT-5 and Gemini 2.5 Pro apparently crushing medical exams.
Yeah, the scores look fantastic. Top percentile on multimodal benchmarks, things like NGM and JAMA.
Exactly. And the narrative that's building is, well, that these models are basically ready for the doctor's
And
office.
that narrative, based on the research we've been diving into today, it seems pretty misleading, maybe even dangerous.
Right.
Our sources are telling a very different story. Quite startling, actually, those high leaderboard scores. They seem to be masking what researchers are calling a fundamental illusion of readiness.
Okay, so that's the mission for us today. We're doing a deep dive into this series of, well, stress tests
Yeah, involving 6 of these flagship models.
across these widely used medical benchmarks. And the whole point of this aggressive testing was to find out why. Why do they score so highly when they seem to exhibit this profound fragility sometimes?
Well, the core issue they uncovered is something called shortcut learning.
Shortcut learning.
Yeah. It's basically when the AI figures out a kind of cheap, superficial path to get the right answer rather than, actually solving the complex problem underneath.
Okay, let's unpack that a bit. What does that shortcut actually look like in, say, a high-stakes medical scenario?
A perfect example they give is diagnosing pneumonia. Now, a genuinely capable medical AI, it needs to interpret the complex features in the chest X-ray, right? The visual
Sure,
evidence.
makes sense.
But in these stress tests, what they found is the models often just ignore the image completely.
Really? Ignore it.
Yeah. They've simply learned that if the text description mentions, say, productive cough plus fever, those words statistically pop up together with a pneumonia diagnosis in the training data.
Ah, so it's just pattern matching.
Exactly. It's superb test-taking strategy, you could say, but it's absolutely not medical understanding.
That immediately brings up the initial problem then. If they're relying on these shallow correlations, they must be easy to fool.
That's what the tests show.
They could completely unravel on tasks that seem really simple, like keeping the same answer if you just shuffle the options, or justifying their prediction with actual sound medical reasoning.
Right. It becomes a fundamental credibility problem, doesn't it?
Right.
Especially for AI in healthcare.
It really does. It forces us to rethink what readiness even means. It can't just be about hitting a high score.
No, accuracy isn't enough.
Okay, so let's break down the types of failures these stress tests uncovered. The researchers sort of categorized the weaknesses into 3 core fragilities. What was the first sign that these models weren't playing fair, so to speak?
Well, the first fragility is what they called succeeding for the wrong reasons.
Okay.
Because these benchmarks are multimodal,
Mm-hmm.
they have text and images. The researchers tested what happens if you just, well, take away one
A
part.
missing image test.
Exactly that. And the leading models. They often kept most of their accuracy, even when that key visual input was completely gone from the prompt. They were guessing correctly, using just minimal text cues, or maybe relying on the structure of the question, like how the distractors were phrased.
That shouldn't happen if the image is actually needed for the diagnosis.
It absolutely shouldn't.
Uh,
And many of these tasks do require the visual information.
yeah. So if they rely on these kinds of cheats, they must be brittle, which I think brings us to the second fragility, brittle performance. This one seems particularly concerning.
It really is. It suggests they have this extreme sensitivity to how the input is formatted,
Meaning,
meaning the models are hypersensitive to trivial changes, things that shouldn't matter. If you just reorder the answer choices A, B, C, D, or you make one of the wrong answers, the distractors, a bit weaker, maybe more obviously wrong, or even make a subtle change to the image,
and the model changes its answer.
dramatically.
Oh.
The predictions shift erratically. Even though the core medical question is identical, the AI's certainty just collapses. It shows a fundamental lack of robust understanding. It's just not stable.
Wow. But the real danger isn't just getting it wrong, is it? It's maybe faking the right answer, or worse, faking the explanation for the wrong answer.
Precisely. And that leads to the third fragility, which is maybe the most ethically concerning: fabricated reasoning.
Fabricated reason.
Yeah, this is a huge issue, especially when we rely on models that are trained to think step by step, show their work.
Right, the chain of thought prompting.
Exactly. When you ask them to explain their logic, they often generate these confident-sounding rationales,
Okay.
that have utterly incorrect underlying reasoning. They might produce a perfectly plausible, medically sound explanation for a completely wrong diagnosis.
Oh, wow.
Or, maybe even worse, they'll get the right answer, but support it with reasoning that requires hallucinating things in the image that just aren't there.
So they're making things up to justify the answer.
They're prioritizing sounding right over being right,
Right.
which is not what you want in medicine.
Definitely not. Okay, here's where we move from the theory to the actual evidence. Let's look at the specific stress tests they designed to strip away those spurious cues and expose these shortcuts. These 6 tests are kind of like clinical x-rays for the AI itself.
Yeah, that's a good way to put it. We can start with the first two, stress tests 1 and 2. They focused on modality robustness, basically, that missing image test again, directly assessing how much they depend on the visual input.
And the results were fascinating, weren't they? Because they showed really sharp differences, even between models that looked almost identical on the standard leaderboards. Tell us about those score drops.
Well, okay, take the NEJM benchmark. When they removed the image, GPT-5's accuracy dropped by 13.33 percentage points. It fell from over 80% down to about 67.5%.
That's a noticeable drop.
It is. But GPT-4o showed the biggest collapse of all. It plummeted by nearly 30 percentage points,
Yeah.
29.62 to be exact.
Wow, that's huge. So the standard leaderboard completely hides that difference in reliance on text versus image.
Completely hides it. It shows one model might be leaning much more heavily on just the text than another, even with similar overall scores.
That score variance is critical, isn't it? It suggests that even slight changes in the input could make a model that looks safe become highly unreliable pretty quickly.
Absolutely. And it also immediately exposed inconsistencies in the benchmarks themselves.
How so?
Well, while any JM scores dropped sharply without the image, proving it needed the visuals,
Right.
the scores on the JMA benchmark items remained relatively stable when the image was removed.
Meaning?
Meaning it told the researchers that many JMA questions are actually solvable almost entirely from the text description alone. So it highlights that not all multimodal benchmarks are really testing the same thing. Some aren't as visually dependent as you'd think.
Okay, that's a key point about the tests themselves. But it gets even worse when you focus only on the questions that absolutely must require looking at the image, right?
Yes. The researchers manually confirmed 175 items where you simply couldn't get the right answer without the visual input. Impossible.
And even on that super strict subset, when the image was missing.
Most models still perform significantly above the random chance baseline, which would be 20% for a multiple choice question with 5 options.
They were still guessing correctly, without the necessary image.
Correct. GPT-5, for instance, still scored 37.71% in that text-only setting on tasks that were visually impossible without the picture.
How? What does that prove?
It proves they're relying on non-visual cues. Things like frequency priors, just knowing which answer tends to be the most common for that type of question, or maybe rate memorization of question-answer pairs they saw during training.
So they're statistically savvy guessers, not diagnosticians.
You could say that, yeah. Very proficient guessers.
But there was one really interesting anomaly here with GPT-4, wasn't there? Its text-only score on that visually required set was tiny, like 3.4%. Why so low?
Yes. That was interesting. GPT-4o frequently refused to answer when the visual input was missing.
It refused.
Yeah. Now, in the standard way of scoring, that penalized its numerical accuracy, right? It got marked wrong. But actually, you could argue that reflects a much healthier, much safer behavior.
How so?
Well, in a high-stakes setting like medicine, you want caution. You want appropriate abstention when critical information is missing. You don't want a confident guess based on nothing.
So losing points for being cautious might actually be a good sign for safety.
Exactly what we want, potentially, even if the leaderboard doesn't reward it currently.
That is actually a huge potential win for safety, yeah. Okay, let's shift gears. How did they test for reliance on the text format itself? Stress tests 3 and 4, the shortcut pattern disruption ones.
Right, so test 3 focused purely on formatting.
Mm-hmm.
The researchers found that just randomly reordering the 4 or 5 answer options, no shuffling A, B, C, D in the text-only setting, caused consistent drops in accuracy across all the models they tested.
Wait, just shuffling the letter choices makes them score lower? Why on earth would that happen?
It proves they're relying on fixed answer positions or some kind of formatting bias, meaning the model might have learned, maybe implicitly, that for a certain type of question phrasing, the correct answer, statistically, tends to be option B in the training data.
No way.
If you scramble the options, that learned shortcut just breaks down. GPT-5 dropped nearly 6 percentage points, 5.7, just from reordering the text choices.
That is such a simple vulnerability. Scary how easy that would be to exploit, intentionally or not, in a real application. Now, Test 4 looked at disrupting their reliance on the wrong answers, the distractors.
Yeah. They tried replacing the existing distractors with completely irrelevant options, things totally unrelated to the medical question.
And what happened then?
Well, predictably, the text-only accuracy dropped towards random chance. The models couldn't rely on their learned associations between the question stem and the usual set of incorrect options anymore. Those familiar wrong answers weren't there to guide them.
Okay, that makes sense. But the truly surprising detail, almost funny if it weren't serious, came from that unknown distractor test. I want to highlight this because it really shows the game the AI is playing.
Oh yeah, that was wild. They replaced just one of the distractors, just one of the wrong answers, with the word unknown.
Okay, so you'd think that might make the model pause, maybe signal uncertainty, or even choose unknown if it's unsure?
That's what you'd hope,
Well,
right? But instead, it actually boosted the model's performance.
boosted. It helped them,
Yes, sometimes by 5 to 8 percentage points across the board.
giving them an easy out option actually helped them score higher. How?
It suggests the models didn't interpret unknown as a signal for genuine uncertainty or a reason to abstain.
Then what did they see it as?
They saw it as a weakened distractor, an obviously incorrect or irrelevant choice they could easily eliminate, which ironically simplified the task of picking the correct answer from the remaining, more plausible options.
Wow, so they aren't aiming for truth or accuracy in the human sense. They're just optimizing for eliminating wrong answers most efficiently.
That's what it looks like. They're playing the multiple choice game very, very well.
That is genuinely unsettling. Okay, now for the final, maybe the most brutal stress test. Test 5. Visual substitution. This sounds like the ultimate trust test, forcing the AI to choose between conflicting signals.
It really was. The setup was critical here. The researchers took the original patient text and the question, but they swapped out the original image. They replaced it with an image that explicitly supported one of the distractor answers, one of the wrong choices.
Ah, okay. So the AI gets a correct text description, but an image that points to a wrong answer. It has to reconcile conflicting evidence.
Exactly. A direct conflict between text and vision.
And what happened when the text and the image fundamentally disagreed like that?
Catastrophe, pretty much. Performance just collapsed sharply across the top models.
How bad was it?
GPT-5 dropped over 31 percentage points in accuracy, 31.66. Gemini 2.5 Pro dropped a massive 33.33 points.
Whoa, what does that expose?
It exposes this brittle reliance on learned visual label associations, like a flashcard memory, rather than robust, integrated visual textual reasoning where they weigh both sources.
So, faced with a conflict, they defaulted to the image.
It seems they prioritized the picture and its associated memorized label over the detailed, conflicting text description right in front of them.
So the internal logic seems to be, trust the learned visual pattern first, ask questions later. Or maybe never ask questions. That seems fundamentally backwards for clinical decision support, doesn't it?
It really does. And then finally, test 6, the reasoning audit. This used that chain of thought, or CO2, prompting we mentioned, basically asking the AI to show its work.
Right, to try and see why it was making these choices.
And to see if forcing it to reason step by step improved things.
And did asking them to show their work actually improve their accuracy?
Well, for most models, CO2 yielded mixed results. Sometimes accuracy went up a little, sometimes it went down. No clear win. Often negative gains, actually. And the manual audits of those generated explanations confirmed the problem. Even when using COT, the reasoning was often completely disconnected from genuine multimodal understanding.
So they could talk the talk.
They could provide highly plausible, medically articulate justifications that were just factually wrong or based on hallucinated evidence. Still fabricating.
Okay. If we try to connect all this back to the bigger picture, this inconsistency we saw, like the models failing hard on NEJM's visual tests but doing okay on JAMA's text-heavy ones, that suggests the failure modes aren't just about the AI, right? It's also about the tests themselves.
Precisely. That's a key takeaway from the sources. The benchmarks themselves vary hugely in what they're actually testing, yet we tend to treat them as if they're interchangeable measures of medical readiness on one big leaderboard.
Which is misleading.
Very. So to fix this, the researchers developed a structured way to profile these benchmarks, guided by clinicians. They used two key axes, reasoning complexity, and visual complexity.
Okay, mapping the landscape. And what did that reveal?
It revealed really important structural differences. For instance, they found any JM tasks rank high on both reasoning demands and visual demands. They're genuinely complex multimodal problems.
Okay, and contrast that with JAMA.
JAMA was profiled as requiring substantial reasoning, yes, but because of how the questions are often written, it's mostly solvable from the text alone. So it has low visual dependence.
Yeah, I see.
And then conversely, you have data sets like VQA-RD or PMC-VQA. These are highly visually dependent. You absolutely need the image.
Right.
But they tend to be lower in inference complexity.
Yeah.
The questions are more about identifying things in the image, not deep clinical reasoning.
Okay, so the implication here is critical then. We shouldn't treat these benchmark scores as just one number.
Absolutely not. They should be treated like diagnostic instruments themselves. Tools to reveal specific AI capabilities and weaknesses, not just monolithic performance targets.
Because when you average scores across these wildly different types of tasks...
You mask the failure modes. You completely lose the nuance. And that risks misinterpreting numerical progress on a leaderboard as genuine, trustworthy, real-world readiness, which it clearly might not be.
So the call is for disaggregated scores, breaking them down along these medically meaningful lines.
Exactly. If a model nails a text-solvable JMA question, but completely collapses in that visual substitution test we talked about, you know exactly where its limitations lie. It's not safe for visual diagnostic support, even if its overall score looks good.
Right. So wrapping this up, what does this all mean for the future of building AI we can actually trust in medicine? What does true medical readiness demand based on this?
Well, it clearly means readiness requires far more than just hitting a high number on a test. It demands reliability, first and foremost, interpretability, knowing why it made a decision, and safety, especially when the system faces uncertainty or incomplete information.
Which, let's be honest, is the daily reality of healthcare, right? Uncertainty and incomplete info.
It absolutely is.
So the path forward seems pretty clear then. Structured stress testing, like the kind we've discussed, it has to become a core part, maybe even a compulsory part of how we evaluate these models.
Yes. We have to move beyond just optimizing for leaderboard scores and actively design tests to find the brittleness, to diagnose these shortcut behaviors.
That seems like the only way to genuinely build trust in this incredibly high-stakes field.
It does. And, that brings us back to maybe the most dangerous failure mode they identified.
Yeah.
The model generating that confident, fabricated, medically plausible reasoning, even when critical visual evidence is missing or contradicts it.
Yeah.
If our trust in AI hinges entirely on its ability to produce justifiable decisions, it really raises an important question for you, the listener, to think about. How should future evaluation protocols be designed? How do we prioritize and reward appropriate uncertainty and abstention?
Right. Should a model actually be rewarded, not penalized, for saying, I don't know, when the visual information it needs just isn't there, or when the data conflicts?
Instead of rewarding it for making up a convincing lie,
Yeah.
that's the challenge ahead.